With a number of growing exoplanets discovered through various methods, one method stands out the most: the transit method. The transit method is the most successful way to detect an exoplanet's eclipse when it transits its host star. The terminology for eclipse is where we are seeing the shadow of the planet's night side. The term transit is described when an exoplanet passes in front of its host star. As it passes, it blocks a portion of its starlight, which we can measure to determine its radius, orbital period, and duration of the event, and other parameters. The transit method is the most widely used technique for detecting exoplanets and is often regarded as the most successful. By measuring the slight dimming of a star as a planet passes in front of it, astronomers can infer the presence of an exoplanet and even estimate characteristics such as its size and orbital period. However, this method alone has certain limitations, as various astrophysical phenomena can mimic the signatures of planetary transits. Missions such as Kepler and TESS implement safeguards to ensure accurate results before proceeding with ground-based observational campaigns. These safeguards help identify and eliminate false positives, ultimately saving time and resources. False positives occur when something other than a transiting exoplanet causes a similar dip in stellar brightness. Understanding the nature of these false positives is crucial for refining exoplanet detection methods. False positives fall into two categories: intrinsic and extrinsic variability. Intrinsic variability arises from the star itself and can interfere with exoplanet detection. These include stellar pulsations, where the star undergo periodic fluctuations in brightness due to internal processes. Solar activity such as sunspots can create brightness changes resembling a planetary transit. Cataclysmic activity seen in stars that exhibit eruptive variability, including red dwarfs or spectroscopic binaries, where two stars orbit each other closely enough to influence each other's output. Extrinsic variability originates from external factors, including eclipsing binary stars, where two stars in a system pass in front of each other, causing a temporary dip in brightness that may be mistaken for a planetary transit. Another factor is a background eclipsing binary system, where a distant binary system aligns with the target star, producing a misleading dip in brightness. Also, instrumental noise, where data inconsistencies from telescopes or observational techniques can create false transit signals. To ensure reliable exoplanet detection, astronomers employ advanced methods to distinguish true transits from false positives. Astronomers use follow-up observations with ground-based telescopes, analyze light curves, and apply radial velocity measurements to verify whether an observed transit is truly caused by a planet's influence on its host star. By accurately identifying and eliminating false positives, scientists improve the reliability of exoplanet discoveries and refine the techniques used in future space missions.